Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 337 House Robber 3. This problem is based out of dynamic programming in trees and has been asked in almost all the tier 1 companies like Amazon, Google, Microsoft, Meta, Adobe. Before jumping to the problem statement, let me tell you that this problem is an extension to existing house robber problem which is quite famous, and we have already prepared a video on that, which is LeetCode problem number 198 House Robber. In this problem, we are given houses in the form of array and we have to choose alternate houses. But here we are given houses in the form of a tree. Now let's try to read the problem statement. The thief has found himself in a new place of his thievery again. There is only one entrance to this area and called root. Okay. From the root he can start. And beside the root, each house has one and only one parent house. After a tour, the smart thief realized that all the houses in the place form a binary tree and it will automatically contact the police if two directly linked houses were broken into the same night. Given the root of the binary tree, written the maximum amount of money the thief can rob without alerting the police. Okay, in the problem statement, they are saying that the thief can start his thievery from the root, and this arrangement is forming a binary tree, and the thief can rob houses which are not adjacent. Let's say for 3, the parent is for this node, the parent is this node, and if the robber is trying to rob this house, he can't rob the parent and the child. In this arrangement, if he rob this one, then he cannot rob this 2 and 3, and he can rob 3 and 1. Right? In other terms, if I try to explain, if a thief has a robber node, only in that case, if the parent node is not robbed, and if it is robbed, the child node will also not be robbed. So this is the scenario that we have to follow. Okay, so in this case, what we can do to get the answer? See, first of all, if we are allowed to rob all the houses, we'll just directly do the visiting of every single node. And how do we visit every single node? By doing the tree traversal. Let's say we are using DFS because tree is a recursive data structure, and DFS, we are starting with DFS so that we can think recursively. Using DFS, I'm visiting every single node. But here, I have to make sure that when I'm capturing a node or when I'm robbing a node, the parent node is not robbed, right? Parent node. See, we are only concerned about the parent node because the child node will automatically be taken care. If I'm robbing this 3, I can't rob this one. If I'm not robbing this 3, I can rob this 2. So let's say if my solution function is something like this, solution root. Whether the parent is robbed or not, this we can take as a boolean flag, true or false. Parent is robbed or not. If the parent is robbed, we are going to skip the current node. If the parent is not robbed, then we can rob the current node as well. We can use this intuition to form our recursion, or you can say modifying the DFS approach, right? Now let's try to see what our code will look like. Here definitely only the root is not sufficient for us. Along with the root, I'm going to take a flag whether the parent is robbed or not. Parent is robbed or not, and initially let's say I'm passing it false because for root there is no parent. It means he can definitely pick root or skip root. Let's say it is returning integer because we have two scenarios. Let's say if we are starting with root, we are picking it, not picking it. And recursively, we can decide. At the end, when I'm returning from it, we have only two options. If going from this direction, whatever is the maximum, I'm going to return that. Let's firstly talk about the edge cases. For 3, the left side is null, right side is null. The amount of money I can get is 0 definitely. So if root is equal to null, then return 0. Otherwise, let's see if I can rob this house. I can rob this house is parent robbed is false. If parent robbed is equal to false, only in that case I can rob this house. So my one possibility is pick the current house value, root dot value is the amount of money I can get, plus now I can either go on the left side or the right side. If I am going on the left side, root dot left, but in this case parent robbed will be true, plus solution root dot right with parent robbed equal to true. So this is my one possibility that I can get. Only in that case if parent robbed is false. What about the other possibility? If parent robbed is true. If parent robbed is true, then we definitely have to skip the root one. So my, let's say, possibility 2 is equal to solution root dot left parent robbed is equal to false, plus solution root dot right parent robbed is equal to false. Let's say when I am skipping it, then I can easily rob this one. When I'm considering it, I can't rob this one, right? So if the parent rob is equal to false, then I can pick the current node. Otherwise I can't pick the current node, I just have to move ahead. So this is my two possibility. These are the two possibility in which a robber can rob, and at the end we just have to return the maximum of these two. Whatever is the maximum of these two, just we have to return. Now this much is the pseudocode for our approach. First case, second case, and this is my terminating case. Let's write down the approach. See, before that, what is going to be the time complexity of this approach? Here the time complexity is every time we are going to explore two possibilities. Let's say we are having n number of node, and for every node we have two possibilities, so it will be 2 raised power n. But you can have a look that this is the call, and the value of root can be n in number, n times 1 2 3 4 5 6, like every node have a root value. Let's say n number of tree nodes we are having, and previous node I have only two possibility, either true or false. So if I just take a table of 2 in 2 cross n, or we can just take a map of tree node and a 2D array, whether true or false. For every tree node we can take a array of 2. If it is 0 means if it is false, what was the value? If it is true, what was the value? So in this case we can cache these calls. If I just cache these calls, what will the time complexity? N into 2. N into 2 means order of n is the time complexity, and the space complexity will be around order of n. So in this way, in this case, we can optimize this approach. Now let's code this approach, and while writing the code, you can have a look how I'm writing the recursive solution. First of all, I will be writing a helper function where I'm going to start from root, and the parent of root is not robbed. I'm just passing false, and this function is going to return the answer to me, returning answer. And now just implement the helper function, private integer solution tree node root, and other thing is boolean parent robbed. Let's handle the edge case. If the root is null, how much money a robber can get? 0, because if there is no house, no money. The second case is if the parent is robbed. If the parent is robbed, we can't rob the current parent. If the parent is robbed, we can't rob the root value. If the parent is not robbed, we can rob the root value. It means the amount of money I can get is equal to root dot value plus pass on further cases, solution and root dot left, but for the root dot left the parent is robbed. Now root dot right, and for the root dot right the parent is robbed, and this is why my case 1. And for the case 1, if parent is already robbed, the case 1 will be 0. What about the case 2? Root the current value I can't rob because parent is already robbed. So in that case I will be robbing starting from left and right with the value that the parent is not robbed, because I can't rob the parent. I was not allowed to rob the parent. And in the end, whatever is the maximum value, return math.maximum case 1 and case 2. Whatever is the maximum, I will just return that. Let's turn over sample test cases. This is just native recursion, which is going to take order of 2 raised to power n time. If 2 raised to power n time, we are definitely going to get TLE. We are having 10 raised to power 4. Okay, TLE we got for 2 cases. So definitely there are overlapping sub problems. Why? Not just because of TLE, because the root value will go from 1 to n, and the p robbed value can only 2 possibility, true and false. If there is a 2 into n possibility, then what is the use of calling this function 2 raised to power n time? So for that I am going to take a, let's say, map I need to take, where I will be caching on the basis of tree node. You might be wondering that why not I just directly take an integer array of size 10^4, because in the constraints it is not mentioned that the node values are unique. See here in the first example, root is 3 and the child node is also 3. So 3 value is not unique. So that's why I can't take the value. So I have to take the tree node. And for the tree node, let's take an integer array. That will be our DP, and this DP is going to be equal to new hash map. And in that case this value will be stored to dp dot get root, and index is equal to this. Index will be based on p robbed. If p robbed is true, then 1. If p robbed is false, then 0. Right? Here using this I have captured it. Why I am directly accessing root? There might be chances if root does not exist. There is one function put if absent. The value is root new integer array. Okay, so this I have added, and now I need to check the value if this value is present or not. Copy if this value is not equal to null. For not equal to null, I also need to take integer wrapper instead of primitive type, so that I can check for null case as well. If it is not null, then return the value directly, because it is already cached. Let's run over sample. Now I have added the caching. Integer should be of size 2. Okay, let's run over sample test cases again. If it is working, yeah, there is no compilation error. I'm submitting the problem. It is submitted successfully. Here I have optimized the time using the caching and using a hash map. I hope you understood the approach. If you get any doubt, you can comment down below. Thank you guys. Bye bye.